welcome to Starfish Maths. Today I'm doing another exam question, and this one's taken from the Edexcel AS paper 2020, and it's question 11. So do take a note of that question or take a screenshot or something, because I'm going to move the screen around, so we will lose that in a minute. This question caught my eye because it's on circles, and I like doing circles, and I've not done any circle work in a little while. I think it was a few years ago that I did the teaching video on circles. I'll try and link that into this video if I'm organised. Let's have a go. Well, it's a pretty standard question, part one, and then part two we need to be a bit more creative, which I quite like. So let's have a look at part one first to get going. We're given the equation of a circle, and we're asked to find the equation of a tangent at a certain point. Very standard question this, so it's nice. 5 marks, so if you can sort of practice this and get this one sorted, then it's quite likely to come up, hopefully, fingers crossed. So we've got the equation of a circle. In that form that they've given us, it's not very helpful. We need to get it into another form so we can pick out the centre and the radius. So hopefully you know which form I'm talking about. It's the form where you can see the centre really easily. So x minus something in brackets. Oh, actually, I'm not going to write that just now. I'm going to write out the equation as they've given us, just so we can do some work on that. So yes, it's gathering the x's and the y's together and putting them in brackets. So it's actually completing the square from here. We want to gather them together and put them into squared brackets. So let's do the x's first. We've got, just looking at the x terms, we've got x squared and plus 18x. So to complete the square, remember you've got to put x plus and then half of that number. So it'll be half of 18 is 9. We halve that to put it in the bracket when we square it. That's completing the square. Again, I've got another video I can link if you're not sure about that. And then we minus off that number that we just put in, the 9, we need to minus that off squared. So minus 9 squared, which is 81. Let's practice that again doing the y's. So the y terms, we've got y squared minus 2y. So we're going to put in y and minus, because it's minus, 2y, half of 2 is 1. So we halve the number and then we minus the number squared. 1 squared is 1. That's nice and easy. And then we've still got the plus 30 and equals 0. Oh, run out of space. Now we can collect together those number bits on the end. So we've got x plus 9 squared, and then y minus 1 squared, and then we've got minus 81 minus 1 and plus 30. That will be minus 52, and I'm going to add it and put it onto the other side, so that will be equal to 52. If you can turn your equation circle into that form, then you can easily pluck out the centre. That will be these numbers here. Just remember to change the signs. So plus 9 becomes negative 9, and negative 1 becomes plus 1. So that is the coordinate of the centre of the circle. Very straightforward. And then this number on this side, 52, that's the radius squared. So r squared is 52. So the radius itself is the square root of 52. So, not 2, 52. That's right, 52. There we go. So now that we know that, I'm going to just draw a quick diagram. I can actually make an actual circle on this thing. Look at that, fancy. And then I'm going to put in, this is a very small diagram. I'm not sure why I did it quite so small. Minus 9, 0. Minus 9, 1 even. That's the centre. Right, what are we asked? We're asked to find the tangent at the point minus 5, 7. I'm going to mark that on, minus 5, 7. When you do these kind of diagrams, do feel free to put in axes. It's just that I've kind of been doing them for so long now, I'm pretty comfortable sort of just putting the points vaguely where they'll probably be, but do put in an axis and scale if you want to, just don't spend too long on it. That's the radius there. We're asked to find the equation of the tangent at that point, which is this yellow line here. So to find the equation of a straight line is very straightforward. You just need two things. You need a point that it goes through. We already have that, it's minus 5, 7. And we also need the gradient of it. So we can get the gradient of it, no problem. You might, if you've done differentiation, be tempted to differentiate the equation of the circle because you know that differentiation gives you gradient. But it's very hard to do on a circle because it's implicit differentiation. You've got the x's and the y's all caught up together. You don't have y as the subject. So it's actually much easier to do a trick using the radius. So if we find the gradient of the orange radius that I've marked in, if we find that gradient, then we can use the fact that they meet at a right angle. Oh, I just rubbed that out. I didn't mean to. Let me draw on a right angle here. So if we find the gradient of the orange line, then we can take the negative reciprocal of that to find the gradient of the yellow line, because we know that perpendicular gradients multiply to give us -1. So it's the negative reciprocal of each other. Let's start then by finding the gradient of the orange line. We've got the 2 points it goes through, so we can use that little formula. Are you a formula person? Do you use formulas? I don't tend to, but that is the formula if you want it. y2 minus y1 over x2 minus x1. I just sort of remember it's the change in y over the change in x. Either way you do it. Let's try. 7 minus 1 is 6. And then the x's minus from each other, -5 minus -9, it gives us 4. So that's 3 over 2. The gradient's 3 over 2 of that orange radius. So I said take the negative reciprocal. That's a fancy word for saying flip it upside down and change the sign. So the yellow gradient, I'm going to write m, will be 2 over 3 and made minus. And that's all it is. So that's the gradient of that line. So I said to find the equation of a straight line, you need two things. You need a point it goes through and you need the gradient. And we've got both those things now. We've just worked out the gradient and we know it goes through -5, 7. So you can use, y minus y1 equals m, x minus x1. That's the formula you can use. Or you can use y equals mx plus c. I've started using this more recently, I don't know why, but there we go. Put in what we know. That coordinate -5, 7 gives us the x and the y. So 7 is y there. M is -2 over 3. And x is -5. And we don't know c, but we can work it out very easily now. So let's multiply everything by 3 to make 21 equals +10 plus 3c. So then 11 is 3c. So c is 11 over 3. Then we can put that back. So y equals, the gradient is -2 over 3, x, and the c we have now found is 11 over 3. And we keep the y and the x now as variables, so we put the letters back in because we want them there to make an equation. And then that is the equation of the tangent. But the exam question asked us to put it in that form where everything is whole numbers and they're all on one side. So we'll just play around with that a little bit to get the form that they want. We'll multiply everything by 3. And then we can get everything onto the other side. So plus the 2x over, plus 3y, and minus the 11 equals 0. And that is the equation of the tangent. Brilliant, well done if you got that. If not, maybe have another go. And we're going to move on to part 2. I wanted to say B then, but it's part 2. As I said, part 1 is very standard, so that's a method that you need to know. Make sure that's okay. And then part 2 is a bit more weird, a bit more creative. I quite like it. We've got a different circle. C2 has this equation, again in that form, so we need to change that. K is a constant. Given that C2 lies entirely in the 4th quadrant, find the range of possible values for K. That's such a good question, isn't it? Let's go underneath here to work this out. So we've got a a circle. I was just trying to remember the word for that. And we're told it's entirely in the fourth quadrant. If you don't know, that's this one here. It goes 1, 2, 3, 4 like that. So it's entirely in that quadrant. And I'm going to sketch this on just like I did in the previous part. So to do that, I'm going to get it into that form again. So we just did that in part 1. So if you didn't do that yourself, now would be a great time to try it for yourself. It's the same skill again. So good practice. Let's have a go. We're completing the square. So the x is first. We've got x, and halving the -8 will be -4. Minus that off squared is 16. And then the y's, we've got half of 12 is 6. Minus that squared. And then again, running out of space, eek, equals 0. So we've got, just tidying that up, we've got x -4 squared and y plus 6 squared. And again, I'm going to gather those numbers and put them on the other side. So -16 minus 36, that is -52. And I'm going to plus that over to the other side and take off the k. So this is what the circle looks like. The centre is at, remember to change the signs, +4 and -6. So even if you didn't know what the fourth quadrant is, should now be apparent that it's there if you've worked out where the circle is. Now, we're told that the circle lies entirely in this quadrant. I didn't use the circle tool, so that's not very good, but I'm just being lazy. Let's have a think about this. The possible values of k. Well, what are the limits? It can't go over, it can't stray over into this quadrant. So what that means is this length here cannot be bigger than its radius. The radius of the circle there cannot be bigger than that gap, and that gap is, what is that x coordinate? It's 4. That gap there cannot be bigger than 4, otherwise it will cross over that axis. It's down at -6 here, looking at the y's, so that distance is going to be bigger anyway. So we only need to look at the tightest corner, the tightest space here, the smallest limit, is what I'm trying to say, is this one here. So that distance is 4. We want the radius to be less than that. Does that make sense? So it's contained within that quadrant. So remember, the radius is given from here. That's the radius squared. So the radius itself will be the square root of 52 minus k. And what we're saying is that radius needs to be smaller than 4. So I'm writing in an inequality. To solve this inequality, I'm going to square both sides. So 52 minus k to get rid of the square root, and then that one will be 16. And then solving that, 52 minus 16 is 36, and plus the k onto the other side. And that's it. So k has to be bigger than 36. Good. Is there anything else that k can't be? Are there any other limits to k? There is actually. This is harder to spot possibly. But a radius can't be negative. You can't have a negative radius, and you can't take the square root of a negative number. So that 52 minus k needs to be bigger than 0. It needs to be positive. So that means that 52 has to be greater than k. K has to be less than 52. And we can actually, you can give that as 2 separate inequalities, or you could add it on, you could write it all in one inequality. So k has to be bigger than 36, but less than 52. So you could write that all as one inequality, like that. And I'm not going to put in the equals because we don't want the radius to be 0 either. And we want it within the quadrant, not touching the axis. So I'm actually going to leave off those equal signs and give that as the final answer. And there we have it. Hope that was helpful, and enjoy circles.